Potential and Kinetic Energy
by Nicolette Conforti,
Brianna Ramos,
and Jasmine Baswell. Have you ever wondered why this happens? It's because of energy.
Energy is the ability or capacity to do work. So when your books fall in the hallway, you could blame energy.
A joule, abbreviated by the letter J, is the unit of measure for energy.
What you just saw was an example of kinetic energy. Kinetic energy is the energy of motion.
What you just saw is an example of potential energy. Potential energy is energy due to position or stored energy.
So as Jasmine lifts the ball, there is potential energy because it has height. And as she drops the ball, there is kinetic energy because there is motion.
As Nicolette stands on the chair, she has potential energy due to her height, but as she jumps, that potential energy is converted to kinetic.
Here are some equations you should know. The equation for potential energy is mass times gravity times height. And the equation for kinetic energy is 1/2 the mass times the velocity squared. The equation for potential energy shows that mass and height are inversely proportional because they are on the same side of the equation. The equation for kinetic energy shows that mass and velocity are inversely proportional because they are also on the same side of the equation.
So here's an example. Determine the kinetic energy of a 625 kilogram roller coaster with a speed of 18.3 meters per second.
Plug in your variables into the kinetic energy equation. Your mass is 625 kg and velocity is 18.3 meters per second. After you plug this into your calculator, you will get 1.05 times 10 to the 5th power.
Here's another example. A cart is loaded with a brick and pulled at constant speed along an inclined plane to a given height. If the mass is 3 kilograms and the height is 0.45 meters, what is the potential energy of the cart?
So to solve this equation, you want to plug in the mass, which is 3 kilograms, and the height, which is 0.45 meters, and the constant for gravity is 9.8 meters per second squared. So you plug that into the equation, and the answer you should get is 13.2 joules.
Follow along as we show you an example. Lift up your pen so that it has maximum potential energy, and then drop it. This way it has kinetic energy.
Now let's look at the law of conservation of energy. The law of conservation of energy states that energy cannot be created or destroyed, and energy can only change forms.
Okay, look how much fun we're having on this roller coaster. It's really cool, right? Well, this is because of the transfer of energy. Because of the law of conservation of energy, at the top of the roller coaster we have the most potential energy, which means that as we get to the bottom, we get even faster because of the transfer of energy to kinetic energy.
The total mechanical energy stays constant the entire ride.
Here's a diagram of what you just saw. As you can see, at the top, there is maximum potential energy because of its height. As the car moves down the hill, the potential energy decreases and the kinetic energy increases. But the total mechanical energy remains the same throughout. Some of the energy is also released in the form of heat and sound energy.
Understanding potential and kinetic energy helps us to understand the world around us. That's why we run and we fall down, we go on roller coasters, and we stretch rubber bands. I hope you've enjoyed this episode by the New Jersey Public Broadcasting Company on potential and kinetic energy.
Thanks for watching!